The only difference between this section and what we've done before is now we have variables on both sides of the equal sign here versus all the ones you just did on that Nearpod and that sort of thing. Those you just had variables on one side of the equal sign, right? And you got it by itself. There's almost no difference except we just have to get those variables together and then we continue the same way we were doing. Okay? We collect those variables, we get them on the same side together, okay? And we always want to keep those variables positive. We don't have to. We could solve it if we made them negative, but if we keep those variables positive, okay, it makes the problem a lot simpler, okay, if we keep those variables positive. So, for example, an equation like this, okay, I have variables on both sides, right? I have 7n on the left-hand side, 5n on the right-hand side. If I want to get those together on one side, I just do the opposite to move the other one over. So I could do one of two things here. I could either move this 7n to the other side of the equal sign, and since it's a positive n, what would I have to do? I would have to subtract it, right? Subtract 7n. I would subtract 7n here, subtract 7n here, but that would give me a negative n on this side. See that? So I would like to try and keep them positive, because it doesn't matter which side the n goes on. So let's say if I want to move this 5n over, since it's a positive, I'm just going to subtract it from both sides. So I subtract 5n there, I subtract 5n there. That goes away. If I have 7n's, I take away 5n's, I'm left with 2n's. Minus 2 equals 6. Now it becomes an equation just like you guys were solving. What's the next step in solving this equation? Thomas, yeah?
Take plus 2
yeah.
on each side.
Undo that subtraction, so I'll add 2 to both sides.
And 2n divided by 2.
2n equals 8. Very good.
And then divide by 2, and then equals 4.
Excellent. So the only difference here, again, was I had n's on both sides. I just moved them together, yeah? And I like to keep them positive. It doesn't matter which side they go on, but if I could keep them positive, it makes it a little bit easier. Okay? So in this case, a short one, 4b plus 2 equals 3b. I could subtract this 4b over here, but that's going to give me 3b's, take away 4b's. That'll give me negative 1b's. I could still solve it that way, but let's try and keep them positive. So let's move that 3b to the other side. Since it's a positive 3b, I need to subtract it. So I subtract 3b here, subtract 3b here. 4b, take away 3b, I'm left with just 1b plus 2 equals, well, what's left on the right-hand side? Yeah, 0, right? So I need to write 0. Okay? Finally, to solve for b, I need to undo that addition. So I just subtract 2, b equals negative 2. Okay? If I want to check my answer, if I go plug that back in here, that gives me negative 8 plus 2, which is negative 6. Well, if I plug in here, 3 times negative 2, that's negative 6. That's true. Negative 6 equals negative 6. Okay? So these, always, if you're unsure if your answer is right, just plug it back in and see what you get. Okay? Okay. So to solve more complicated ones, sometimes we need to use a distributive property first to simplify. So, for example, here, before I can start moving stuff back and forth, I need to get rid of those parentheses. Okay? And how I get rid of those parentheses is use that distributive property. I take what's on the outside, and I multiply by everything on the inside. So I'll just rewrite everything else so far. 2 times x is 2x, and 2 times positive 2 is positive 4. So also I want to look on the left and right hand side. Is there any like terms that I can simplify to make this problem shorter? Yeah, on this left hand side, okay, 15 and negative 9, those are like terms, so I can simplify those. That becomes a plus 6. Okay, equals 2x plus 4. Okay, I want to look, all right, let's get those x's together on one side. I can either move that 3x over, or I can move the 2x over. Which one should I move over to keep them positive? Yeah, let's move that 2x over. Okay, since it's a positive 2x, how would I move it over? Subtract it. Okay. If I have 3x, I take away 2 of them, I'm just left with 1x. I'll rewrite everything else. Finally, I just left with the plus 6 to get the variable by itself. So I will subtract 6 from both sides, and x is negative 2. Okay, see how that works? So simplify the left-hand side and the right-hand side first. That way it makes the problem shorter, right? I could simplify here. I made that 6. I could simplify here. I used a distributive property. I went from this long problem to here just by simplifying the left and right-hand side before I continued. Okay. So the reason I threw this one in here, first, let's just look at the left-hand side first. Let's just look at this left-hand side equal sign. Are there any like terms on this left-hand side that I can simplify? Yeah, I have, remember like terms means they have the same variable to the same power, then you can add and subtract them. So if I have negative 6a's and I add 4 of them, right, I'm down 2a still. All right, let's look at the right-hand side. Okay, I can get rid of these parentheses by using the distributive property. But what number am I actually distributing here? The negative 5, right? Because you always got to keep the sign that's in front of the number. So I still have the negative 1 out front. Negative 5 times 7, negative 35. And then negative 5 times negative 2a. Is that going to be add or subtract? Since it's a negative times a negative, right, add, sorry, 5 times 2, 10a. So now I made the problem a little shorter. Let's look. Can I simplify these two? Can I subtract these two? Why not? Yeah, they're not like terms, right? What about on this side? Do I have any like terms? Yep. These two are like terms. If I'm down $1 and I take away 35 more, I'm now down $36. Now it's became a really short problem. Let's get those a's together on one side of the equal sign. I can either add 2a to both sides, or I could subtract 10a from both sides. Doesn't matter which way you do. I'm going to go ahead and add 2a. That way I keep them positive. That goes away. I'm left with 4 equals negative 36 plus 12a, because 10a plus 2a is 12a. What is my next step in solving this equation? Yeah, move that negative 36 to the other side. How do you do that? Good, add it, because it's a negative. Add 36, add 36. I'm left with 40 equals 12a. Okay. Finally, to get rid of that multiplication by 12 that's happening to the variable, I will divide both sides by 12. Okay. 40 divided by 12 doesn't come out evenly, but I can just simplify that fraction. Both of those have a common factor of what? What's a number that goes into both of those? 4, right? So if I divide 40 by 4, I get 10. If I divide 12 by 4, I get 3. So I can just leave it as 10/3. Or you could make it a mixed number if you want. It'd be 3 and 1/3, right? Okay. So that's a little bit longer one, but it's nothing we haven't really seen before, right? Combining like terms, getting stuff together. Okay. Simplify on the left and right hand side to make the problem shorter first. All right. These problems, the identity, let's go over these. You don't have any of these on your homework right now. They may come up sometime, okay? Identity is an equation that's always true no matter what you put in for the variable. No matter what number you put in for the variable, the problem always works. So for example, in this problem, let's go ahead and start solving this one, okay? And we'll go through this kind of quick because I want to get to your homework. You have like terms here, 10 plus 1, that's 11. You still have minus 5x. And then you have like terms here on this side, 7x minus 12x is negative 5x plus 11. Okay, let's get those x's together. Let's add 5x to this side, add 5x to this side. Will that become 0? Will that become 0? I'm left with 11 equals 11. Is that true?
Yes.
Does 11 equal 11? Well, it's true, right? Because then if I subtract 11, I get 0 equals 0. Also true, right? My variable just kind of disappeared. Okay? This is true. This means there are infinite solutions, okay, for this problem. It means it doesn't matter what you plug in for x, this problem works. Let's say if I plug in x is 2, and I'll do this really quick. 10 minus, this becomes 10 plus 1 equals 14 plus 11 minus 12. I just plugged in 2 for x. Well, 10 minus 10 is 0, plus 1 is 1.
Wait, that's an x. That's
Wait, did I I forgot, that's 24, right? Thank you. And I'm
negative 10 is negative 10x.
10 minus 10 is 0, right? Plus 1.
Oh, yeah.
And then 14, that's all right. 14 plus 11, 25, minus 24 is 1. So 2 worked, right? Because I got something that's true. What about if I plug in x is 3? Well, that becomes 10 minus 15 plus 1 equals 21 plus 11 minus 36. Well, this is negative 5 plus 1 is negative 4. This is 32 minus 36 is negative 4. That also works. That's true. See how that works? There's infinite solutions. You can plug in whatever you want for x here. The problem's going to be true. Okay? So that happens sometimes if your variable goes away. The other option, okay, is if the variable goes away and you get something that's not true. So let's solve this one, and I'll do this real quick because we don't have any of these. We're going to do our homework together. If I have 4 y's, I take away 1 y. I have 3 y plus 7 equals 10 plus 3 y. All right, let's get our y's together on one side. So let's say I subtract 3 y over here, subtract 3 y over here. That leaves me with 7 equals 10. Does 7 equal 10? That's a false statement, right? That is not true. That means there is literally nothing you can plug in for y in this problem that would make this problem true. Because whatever you plug in for y, whatever you get will be false. For example, let's say if I plugged in y is 1. 4 plus 7 minus 1 equals 10 plus 3. That becomes 10. That becomes 13. That's false, right? 10 does not equal 13. So we say there are no solutions to this problem because whatever you get is false. Okay? Same thing in these ones, okay? So that's what would happen in those. You either get no solution or infinite solutions if you don't get down to x equals something or the variable equals something.